Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of real-world quadratic functions. This is standard A.8B in the great state of Texas, and we are using item number 13 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we've got an experiment. We've got some x's and some y's about the speed. We got the miles per gallon here. And if we take a look, it does look like, our y value as the x value is increasing, right? It looks like our y value is increasing, and then it kind of hits that peak right there, right? And then it kind of goes down. So I kind of see it kind of going like that as the x value is increasing. It looks like we've got that peak of like 30.1. So that does look like it's going to be a quadratic. They do also give that to us. So we need to estimate the value, the miles per gallon when the speed is 65 miles per hour. But if we look down, obviously that's just an estimate, right? So we could definitely say it's not going to go up, and it's not going to go up. So obviously A, just off the eyeball test, looks like it's going to kind of follow that pattern. You notice how it's going up and it's going back down a little bit, but we need to do a little bit better than that. So let's go ahead and just pull out our calculator, okay? Because we can actually use our technology here. So we are going to go into our stat. We're going to edit, and we're going to just use these as our list 1 and our list 2. So we're going to enter in all of our L1 as our x coordinates. Okay, so 35, we've got 40, and then we've got 50, and then we've got 60. All right, obviously you want to make sure that you are getting those in correctly, and then let's get these in precisely as well. As our y coordinates is our list 2, 28.3, 29.1, and then we're going to use a regression model to pick up an estimated quadratic formula that we can use to then plug in that x equals 65. Okay, so it looks like we've got everything working there. Right, so we're going to go back to stat. Now we're going to go to calc. We're going to go to this, since we're doing quadratics, right? We're going to use this quadratic regression. We've used linear regression for other things. We've already got our x and our y, but we want the quadratic regression because it gives us that. And in this standard form, right, so let's open this back up. In this standard form, let's get blue, right? So y equals ax squared plus bx plus c. Okay, the regression model says, all right, a equals that negative 0.007. So y equals negative 0.007 x squared plus b is, let's call it 0.689. I'm just going to round to the thousands. 689x, and then plus our 14.115. Okay, so that's our standard form there. Now, how does that help us? Well, let's plug in this 65, right? That's what we're looking for. So now we're going to just clear all that. Alright, so let's go ahead and just plug this whole thing in. And we're going to substitute in 65 for the x, so it's going to be negative 0.007, and then let's get that 65 squared, right, and plus 0.689. Let's make sure we get everything there. 9, there we go. Let's get that 9 in there, and then 65. And then we are going to add that 14.115. 14.115. And what do we get? We get about 29. Okay, and we were guesstimating. What were we guesstimating? A little bit more. We were guesstimating about 28. So that's going to be 29.325 is what they say. So 29.325 is that guesstimate. So what is going to be closest to that? We see is going to be that A is our closest, so that is our answer.